All right, cool. So I'm just going to jump into it.
Yeah, so we'll just wait for 1 minute for people to join in.
Okay, cool.
Yeah.
Of course.
We just finished a session on IPFS.
Oh yeah.
Filecoin, yeah.
Oh great, I love IPFS.
Yeah.
Filecoin team is Protocol Labs is a really impressive team.
Yeah. Right, I think we'll have more folks joining in, but then that's fine. Right, everyone, really glad to have Patrick from Chainlink over. And yeah, Chainlink, has been, it's a lot of interesting use cases you can build on Chainlink. They have $4,000 in bounties this time. We had some great hacks built last time, and really looking forward to things. And yeah, Patrick always puts in the effort to make it, keep it interesting. Yeah, looking forward to it. Over to you, Patrick.
Awesome. Thanks so much, Denver. And hello, ETHOdyssey. Really excited to be here presenting a little bit more about Chainlink. For those of you who are brand new to the space, welcome. I know there were a lot of new people who signed up for this hackathon. Really excited to have you guys in the space and at a DevFolio hackathon, which are always fantastic events as well. So really excited to jump in and talk to you a little bit more about empowering your smart contracts and enabling them to do so much more and become these superior digital agreements that we want and need them to be. So I will be monitoring the Q&A feature. I will pause periodically. I'm going to just kind of give the, I have spots in the presentation where I'm going to pause. So please leave questions, post questions in the chat. I love having these be collaborative so that we can kind of get the most out of them. And there's only, looks like there's around 60 people here live, which is a great number. So we can talk and we can Q&A. So with that being said, yeah, so we're going to talk about hybrid smart contracts and decentralized Oracle networks and really why we're doing kind of everything that we're doing, right? Why are we doing this? Why are we at this hackathon? Why are we building these protocols? Why are we building these products? So first, obviously, it starts with a blockchain. Blockchain is this incredibly secure, reliable, decentralized network. It's this shared ledger, not controlled by a centralized authority, right? And this is kind of this key principle that makes the rest of this all work. These blockchains allow us to build these things called smart contracts, right? So what is a contract? A contract is a binding agreement between one or two parties legally, right? It's this legal document that states and explains a formal agreement between two different people. And we've seen this technological evolution of these contracts, right? We've had, verbal agreements. If you do this, I'll do that. We've had telegraph agreements. We've been able to send fax machines. We've these digital agreements where people digitally sign them by like typing in their name. But now we've reached a point with smart contracts where it's much different now, right? Instead of it being this world where we have to trust that the other party is going to do what we want them to do, it actually cryptographically, mathematically does exactly whatever the math or whatever the contract says. So it's this next level of what our typical contracts allow us to do. Now, in the regular world, we have some type of performance data and contract terms, and the participants of the contract will execute, those things, right? That you have to trust, though, that these parties are going to do and execute their end of the bargain, right? We saw a fantastic example of where this actually breaks down recently with Robinhood and GameStop and AME and all that stuff. Robinhood, and actually not even just Robinhood, the entire financial market had painted this picture saying, hey, this is what democratized finance looks like. Anybody can participate. You can all jump in. This is what the world looks like. And it ended up breaking down when all these promises that these institutions made didn't actually come true, right? They painted this picture of, hey, this is what the world looks like. And in fact, that's not what the world was like at all, right? We had these agreements, we had all these promises from this group that didn't actually get fulfilled, right? They said, here's what the world looks like. And that's not actually what it was, because behind all these closed doors, they had all these different rules and whatnot. So smart contracts are this new paradigm that can move away from these brands that always have these promises and always say, hey, we're going to do this, we're going to do that, and then never actually fulfill. Smart contracts are these self-executing contracts with terms of the agreement directly written in computer code. Programmatically implemented a series of if-then rules without the need for any third party or centralized authentication or intermediary, right? So these smart contracts just automatically execute, and they live by kind of this code is law mentality. Now, smart contracts, obviously they run on the blockchain, and they need some type of input and output for them to actually execute. And they're these superior digital agreements, right? It's that these contracts that we were just talking about, but it's the next level of them. They're more secure, right? Because they're tamper-proof digital agreements that can't be influenced by a single party. They have this guaranteed execution layer because it's going to work. It's going to be executed on this decentralized blockchain. They have transparency, which is something that we've never seen really before, where everything that the code is going to do is right in front of you. It's right on the blockchain. Everybody can see it. We have this trust minimization, which is this key piece where we don't have to trust that, you know, these third parties, these other people are going to do the right thing. And then of course we have efficiency, right? They are executed like that, incredibly quick. You don't have to wait 3 to 5 days for something to process. You know, the code is just going to automatically run and automatically get the output. So these smart contracts are solving our society's critical trust issues, right? Right now, if you have somebody that you're working with, like a brand, they're saying, hey, we're going to promise you this, we're going to promise you that, we're going to promise you this other thing. What happens when they back out of their promises, or they lie to you, or their service breaks down? All we can do right now as consumers is walk down the street to the next brand who's going to give us the exact same set of promises. And we're going to hope that this time they're not going to lie to us or be corrupt or anything like that. This is this huge counterparty risk. It's incredibly high, opaque. Transparency is often purposely removed. And then interest yields in this type of trust guarantees is getting lower and lower. Now, smart contracts offer us this solution to move towards, instead of paper brand-based guarantees, to cryptographic math-based guarantees, where counterparty risk is a lot lower because everything that's going to happen is written in code, right? And these brands, they can't influence the code. They can't change things based off of whatever needs that they want, right? So we're moving to this way incredibly more safe, incredibly more transparent world. Now, these smart contracts are fantastic, right? They're solving all these issues that we just went over. However, they have this issue, right? They cannot connect to external systems, data feeds, API, existing payments, or really, you know, any other resource on their own. And this is obviously a huge issue because we want these smart contracts to be these amazing digital agreements that we just talked about. Now, the reason that they actually can't connect to the real world is because they're deterministic by nature, right? And this is actually really good and really important that they're deterministic, because since they're deterministic, we can have all these math-based, all these cryptographic-based guarantees. Now, it falls apart if you try to introduce this random, this weird data, right? If you introduce this non-deterministic data, these nodes are going to go talk to each other to try to reach a consensus, and every node's going to have a different opinion on what the world looks like. So for example, you know, if you tell the entire blockchain, hey, can you all get a random number? Every node has a different idea of what a random number is, and they're not going to be able to reach a consensus. If you tell them to make an API call, well, depending on when they made the API call, the API could have changed, been depreciated, been malicious, etc. And none of the nodes are going to be able to sync up, right? So it breaks consensus, introducing this non-deterministic data into these consensus protocols. And this is a huge limiting factor because it's not going to allow our smart contracts to connect to market data, retail payments, bank payments, you know, events data, really anything. So this blockchain is this awesome, amazing paradigm, but it's, you know, it's stuck in its little virtual world. It's stuck in this walled garden, and you know, it's fun, but it can't really do too much other than that. Well, that's where oracles come in. So a blockchain oracle is any device that interacts with off-chain world to provide external data or computation to our smart contracts. These are these bridges that take these walled gardens out of their isolation, so these smart contracts can actually be used in our day-to-day and really replace these paper-based, these brand-based contracts that are plaguing the world today. Now, there's one other point about this. So the Oracle problem is this combination of smart contracts themselves can't connect with the real world, and the fact that centralized oracles are this point of failure, right? We've done all this work to make our decentralized smart contract settlement layer decentralized. However, if you have a centralized oracle, you've now reintroduced that single authority point, that point of failure, that somebody can flip a switch and turn your entire protocol off or make it malicious or do whatever that they want to do. So centralized oracles are a huge point of failure. If someone says, okay, I have this awesome decentralized protocol, but I'm going to go get the data, I'm going to provide the data. Well, now whoever's providing the data, if it's me, I'm now this centralized point of failure for my entire application. And that ruins the purpose of building on blockchain in the first place. Now, not only is the node being centralized an issue, but the data sources need to be decentralized as well. And this is what we kind of call the highest tier of decentrality, when your nodes are decentralized and your data sources are decentralized as well. There are cases where you can have like a centralized node and a centralized data source. However, that's going to be apparent in your smart contract, and you just need to have the proper mitigation in place. But for the most part, the vast majority of protocols that we want to use and we'll want to engage with need to have this decentralized data and this decentralized logic layer, or this decentralized computation and decentralized logic layer. So the solution to all of this is a decentralized Oracle network. And this is where Chainlink comes in and provides us this solution that we so desperately need to bring our smart contracts into the limelight. So a decentralized Oracle network is a combination of many of these different oracles, right? These different bridges. So we talked about before that oracles are this bridge between the real world and the smart contract world. Now, if you take sufficiently many of them, put it together, you can now bring in different data points and do different computation in a decentralized manner to keep your smart contract settlement layer decentralized and your off-chain external world decentralized as well. Here's a quick visual of what that actually looks like, where we have this off-chain component where all these Chainlink nodes are talking to each other. They're all getting different pieces of data. They're reaching some consensus amongst the data, and then they're sending that data to the smart contract for the smart contract to digest, and can be this wonderful reference point that's cheaper than every single application, making these API calls themselves. And anybody can use this and start to build these incredibly powerful applications based off of this data. And this leads us to what's called hybrid smart contracts. So hybrid smart contracts are this combination of on-chain and off-chain systems. And most of the time when we're talking about smart contracts, we're usually actually talking about hybrid smart contracts, because a lot of the top smart contracts protocols are some type of hybrid, like Synthetics, like Aave, like SushiSwap, like Uniswap. They're all using some type of off-chain component at some point, right? And this is incredibly powerful, and this allows these applications and agreements to, again, have that real-world effect and really replace these on-chain walled gardens, if you will. So in our hybrid smart contract world, we have our on-chain data, which is going to be your Solidity, which is going to be your smart contract code, which is going to be your layer one, if you will. It's going to be your blockchain, like Ethereum, like Polygon, Polkadot, etc. And it's also going to have some type of off-chain data and computation component, where you can have off-chain data, like the price of different assets. You can have enterprise systems. You can have traditional payments. You can have decentralized services like keepers, fair sequencing services, etc. And these allow us to keep this math-based agreement cryptographic and allow them to have more and more incredibly powerful features to really be this contract, this traditional contract upgrade. And yeah, like a perfect example of this is going to be with weather data, right? So you're going to have all these different data sources for rainfall, temperature, or other product evaluators. All that data is going to get routed through a network of Chainlink nodes that are going to then be reported on chain to these weather contracts, right? And they're all going to be these points of reference for applications like Arbol to build weather insurance, right? If a farmer needs crop insurance, right? If it doesn't rain enough, and an insurance provider says, hey, we don't want to pay out, a smart contract would say, well, too bad, you have to pay out. And since it's self-executing, it automatically is going to deliver the funds to the claimee. And it creates this world where you can create incredibly complex and incredibly powerful applications to help the world grow and be better. So I'm going to pause real quick, take a couple of questions here. Is there any way I can connect IBM quantum computing with a smart contract using Chainlink? Yes, I don't know that much about IBM quantum computing, but basically the answer is if it has an API, the answer is yes, or like an HTTP GET or POST, the answer is yes. Check out the any API in the Chainlink documentation. If IBM quantum computing has an API, you're good to go. And I would bet that they do have one. Are these off-chain components centralized to some extent? That's a good question. And it depends on the off-chain component that you're working with, right? Since Chainlink is a customizable technology, you can make it as centralized or decentralized as you really want it to be. So it's kind of up to you. We'll talk about some of the specific kind of out-of-the-box solutions here and the different centrality behind them. But ideally, you have your decentralized price feeds or your decentralized keepers or whatever that bring the data or do the external computation in a purely or as decentralized as you can way. Obviously, decentrality is always going to be a gradient. Some people argue that something like ETH2 is less decentralized than proof of work because staking, and so it's always going to be a gradient. But great question. How to have payment like PayPal and link it with smart contracts? Again, the answer is there is going to be in the any API feature. I'll get to that in a little bit. Great session. I was building with external adapter today and was looking into different jobs and data providers. I was trying to return some more data and then just one value as in the data provider job. So how can I do that? I tried, didn't work out well today. Trying to return some more data than just one value. Okay. So what you're looking for actually is it's called multi-word responses. It's not live yet. It's coming out soon. So what you're looking for is multi-word responses. Sorry, I kind of mumbled over your question there, but yeah, Prince, you're looking for multi-word responses. So Chainlink acts as a middleware to connect off-chain database to on-chain smart contract. Yes, or off-chain computation. And we'll see that in a second too. Great question. How to train neural nets / sell computing power like Google Colab. That question might not relate here. Jump into the Discord and maybe we can kind of dive into what you're looking for there. All right, I'm going to keep going. Great questions, guys. Great question. So one of these pre-boxed features that we want to talk about is Chainlink price feeds, right? And this is this incredibly powerful feature for decentralized finance. Now, DeFi completely redefines users' relationships with markets, right? We've seen DeFi explode recently, and it's this wonderful way to interact with in the financial world, having true autonomy of our funds, having non-custodial ownership of our funds, being able to work with these protocols and interact with these protocols. And it's just been this amazing paradigm. Now, all these DeFi protocols, a lot of them need to figure out what the price of an asset is in some way, shape, or form, right? Pricing data is the backbone of really any high scale or powerful fintech application. And it's no different from DeFi. All these price feeds, getting accurate pricing data is incredibly powerful. So what Chainlink, the Chainlink protocol has actually done is built this kind of pre-boxed solution where all these nodes get together and they get data from many different data providers, and they provide data on chain to be these reference contracts, to be these reference points of truth of what the price of an asset is. And this makes it even cheaper than building your own centralized Oracle, while also being the most highly secure and reliable. You can check it out at data.chain.link, where you have all these cryptocurrency pairs or these cryptocurrency feeds where you can just kind of jump in and see kind of all the different independent nodes that are on these systems. So when we're talking about decentrality, every single different node has a different identity, and this adds to the decentrality of the application. And you can check that out at data.chain.link. You could also check that out at docs.chain.link, where there's a much longer list of all the different data feeds that you can actually use. You can always also request a data feed or build one yourself if you're looking for something else there. Now, these data feeds are incredibly powerful, and they're used by some of the top protocols in the space. some of these numbers are probably even outdated at this point. You have a protocol like Aave, which uses these price feeds to value the underlying collateral for their borrow and loan. So it's an essential piece of their entire protocol. You have something like Synthetics, which is using it to mint their synths. It's using the prices again to measure how much their collateral is worth. So it's an integral piece there. And then SushiSwap for margin trading, set protocol for commodity money. And then some of these numbers, like I said, are a little bit outdated, but you have a protocol like Aave, which is securing, $10 billion, $11 billion in assets under management. You have something like Synthetics, 3 billion, which I think is probably more at this point. But you have all these protocols where so much value is riding on these price feeds being correct, that these price feeds are incredibly battle tested. They've been fueling all these DeFi protocols for a long time now. Just goes to prove that these are these incredibly secure, incredibly quick, incredibly reliable systems. And the best part is they're easy to access and they're on chain for anybody to use. So incredibly powerful. And just a quick point on DeFi. DeFi is incredibly interesting, especially for hackathons like these, because DeFi is like 4% of all value in cryptocurrency, right? And a fraction of all the value in the overarching like fintech world. So if you're looking for more places to build, more things to do, DeFi is a fantastic space to get started, because there is so much growth to be done there. And these price feeds, or really any of the Chainlink services, are incredible ways to build these really powerful applications right from the get-go. So that's a little bit about price feeds. Again, it's this kind of out of the box, decentralized solution, ready for you to go, ready for you to start digesting and building these incredibly powerful applications. I'm not going to have enough time in this presentation to kind of show you guys a demo, but I will show you the documentation really quickly. And all the code is copy pastable. Drop it into your program or your project and you're good to go. So next is Chainlink VRF. So random numbers are really tough in deterministic systems, right? For those of you who have studied some computer science, you know that even when your computer calls like math.random, it's not really calling a random area. It's actually picking a spot of memory saying, yeah, this looks random enough, and using whatever value is there as the random number generator. In blockchains, where everything is deterministic and everything rides kind of on so much money, getting a random number like that is highly, highly exploitable. And we've seen exploits where a miner is going to manipulate the random number, or someone's going to brute force the random numbers. It's going to cause your protocol to have this huge amount of risk that you definitely don't want to take. So in order to get around this and get around this random number issue, where smart contracts and Solidity don't have a way to create true random numbers, Chainlink has gone ahead and created this solution called Chainlink VRF, or Chainlink Verifiable Randomness Function. And it's a way to get a provably random number into our smart contracts. So again, because we can't get a random number in a deterministic system, we have to look outside the blockchain to a Chainlink node, which will provide us a random number. And one of the most powerful points of this whole thing is that there is an on-chain smart contract that can actually cryptographically verify whether or not the number is truly random. It's a mind-boggling phenomenon that you can actually prove whether a number is random or not, but Chainlink VRF allows it to happen. Now, having these truly random numbers has given rise to a ton of different protocols. Aavegotchi and EtherCards are two examples where they create these NFTs with provably random attributes, which creates true provable scarcity. A lot of times what we see in like trading card companies is they'll kind of just print an arbitrary number of cards and say, hey, these ones are rare, just to try to make a lot of money. But this way you can create true scarcity and true randomness in your applications. And we've also seen a number of protocols like Pool Together, have it use this random number in their lottery system, which is absolutely phenomenal. So then I also want to talk about the Chainlink Keepers Network, which is a newer kind of out of the box solution here. And it is incredibly fantastic, and it's leaning more away from the data component and more to this external computation component. So right now, when you want a protocol to be updated, maybe you want to rebalance a portfolio, maybe you want to top up some contract with some ETH or something, you have to manually do that. Or you can rely on some centralized service to do that. However, if your protocol natively needs to be upkept or have somebody push a button, smart contracts can't trigger that. Somebody always needs to trigger it. So Chainlink actually has a decentralized network of Chainlink keepers that are checking this registry, constantly looking for upkeeps or looking for triggers to be called. So they have all these contracts. So in this example here, on the right side, we have all these contracts that are Chainlink keeper compatible. And they're saying, hey, we want you to do something. And the Chainlink keepers keep checking to see when they want it to be done. If a smart contract returns true, in this example, the Uniswap one is saying eligible, the Yearn is saying ineligible. But if they say true, excuse me, then they actually return some data saying, hey, here's what I'd like you to do. The Chainlink node gets that data, and then it performs whatever those upkeeps say, tell it to do. So it's a decentralized way to actually do like a cron, or maybe do some event-driven based interactions where traditionally a human or some centralized service would have to do it. So this allows us to create decentralized protocols that have autonomy, that can be automatically upkept or really do anything, any type of external computation. And this is incredibly powerful. And it's currently in open beta. So if you're looking to explore something really new, work with something really powerful and do some cutting edge stuff before anybody else can, now's your chance. So get in, build something really cool, give some feedback, and we'd absolutely love to see what you're building. But in any case, so this is all just to say that Chainlink is this system to allow end-to-end reliability, right? It's allow you to really do anything you want to do. And if you want to even build your own service or build your own application, you absolutely can. Chainlink external adapters and Chainlink API calls are a way to do this. Again, you can check that in the documentation. But those are some of the pre-box services, whereas Chainlink allows you to customize your application to really do anything that you want to do. So incredibly powerful here. Again, you can head over to docs.chain.link, and I wanted to really quickly show you the price feeds, because this is all the code to have a contract return some data from a price feed. You have some randomness here using keepers on the left side, any API. This is that full customization piece. We have some blogs and some videos on building external adapters, which will take it to the next level if you want to build some type of Chainlink service, which is incredibly powerful. And for those of you who are looking for some testnet ETH or some testnet Link or something like that, the Link token contracts page, this page always has the most up-to-date Ethereum faucets, Chainlink faucets for working with testnets. So it's incredibly powerful. And I'm running out of time, so I will speed this up a little bit. For those of you looking for some inspiration, 77 smart contract use cases enabled by Chainlink. Absolutely phenomenal blog if you're looking for some inspiration. You can learn more, again, at docs.chain.link. You can go to our blog where we have a ton of tutorials on how to build just a ton of different applications, lotteries, staking applications, NFTs, fetching with IPFS data, using some hardware integration. Our Chainlink YouTube has a ton of developer workshops, doing code alongs where we code literally everything right in front of you so you can follow along. Our Solidity and smart contract starter kits are fantastic for people who work with Brownie, Truffle, or Hardhat. It has all the code in it already for you to create a successful project with Brownie, Hardhat, or Truffle. And they are great places for those looking to build really powerful applications. And always, you can jump into the Discord chat. I know the DevFolio has a Discord chat as well. We will be in there, so please ask questions. Documentation, like I said, the starter kits. And if you have questions, Stack Overflow is a great place. Jump into the Discord, ask on Stack Overflow, ask on Stack Exchange ETH, because there's a lot of people in the community who are incredibly intelligent, looking to help, and it's a very collaborative community where everyone's helping everybody out. So please don't be afraid to reach out, ask questions, and learn some more. So it is 30 minutes past the start time. I'm going to stop sharing. And Denver, do we have time for me to answer the Q&A, or do we got to cut it off now?
No, go ahead. And I'm impressed how you managed to do exactly 30 minutes. Exactly 9:30.
I was watching the clock. I was watching the clock, Denver. But yeah, okay, cool. If I have a few minutes, I'll jump into some of the questions now. So I'm looking in the Q&A first, and then I'll jump into the chat. So got a question. What is Chainlink 2.0 about? This is a fantastic question that we probably don't have enough time for in this session. There is a lot of upgrades to the system for to talk about like staking and talk about data DAOs and talk about all these different services that that Chainlink can do in a more efficient and a better manner. You know, just like how pretty much every protocol is constantly improving. Chainlink 2.0 is this is kind of this improvement on the Chainlink protocol. And yeah, I don't really have enough time to go over it now, but if you want, there are a couple of podcasts where Sergey talks about it, where a couple different members of the community talk about it that are fantastic. Jump into the Discord, ask a couple questions, say, hey, where can somebody point me in the direction of Chainlink 2.0 information? I'm 100% certain somebody will point you in the right direction. So not enough time to talk about it now, but also white paper, it's fantastic. If you're looking for really all the nitty gritty, the 2.0 white paper is fantastic. Can Chainlink solve interoperability problem in blockchain? That is a fantastic question. And the answer there is basically to one blockchain, another blockchain is just data, right? So using Chainlink as a middle layer to connect these two blockchains can absolutely be done. And we're actually seeing a couple of protocols and a couple of projects jump onto this very problem. And so a solution like that doesn't exist yet. However, I mean, I personally think yes, and I'm very excited to see solutions that that attack this problem. And because yeah, like I said, you know, one blockchain is just data or computation to another blockchain. So really excited to see projects jump on that. How does Chainlink create new decentralized sources of data, given all existing are essentially centralized? That is a fantastic question. So, oops. So let's say you're an exchange, right? And you're reporting the price of some cryptocurrency asset. You're saying the price of you know, ETH is $10, for example. Now, in that one instance, that one exchange is saying, hey, the price of ETH is $10, and it is centralized by nature because there's that single data provider, right? However, if you go to 50 exchanges and you ask each one of them who's reporting their own prices, what the price of Ethereum is, you've essentially now decentralized the data. So Chainlink on a data front is getting the data from multiple different API providers and exchanges and aggregating them to come to this reference point of truth. So that's a really good question. And pretty much all the data providers, they pull data from some of the highest quality data providers to bring this incredibly secure, reliable, decentralized point of reference for anybody to use. Great question. Is there any decentralized identity use case which you think is not implemented yet using Chainlink? Yes. Amazing question. It sounds like you're walking down the path of building a really cool protocol. So decentralized identity is something that's a massive unsolved problem yet in the smart contract world, right? We don't have a great way to verify people's identity. But again, someone's identity is what? It's off-chain data to a smart contract, right? So Chainlink can jump in and solve that problem as well. If you have some awesome ideas for building that out, this is the hackathon to do so. So great question. Excellent question. You guys are on point. Does Chainlink external adapter make the Oracle centralized? Great question. So if I'm the only one running the external adapter, then yes. If multiple people are running the external adapters and different versions of that external adapters, then no, right? So you got to keep in mind who's running it, who's running the code, who has the code, right? If every single node has their own version of the external adapter, if every single node has a different external adapter, then no. So fantastic question. And the answer is just goes back to architecture, right? One node's running it. Yes, it's centralized. Multiple nodes are running it and different versions of it. That's decentralized. Great question. How Chainlink smart contract verify if a number is truly random? I would recommend going to our blog that talks a little bit about it and checking out the actual contract, right? All the code is going to be in the Chainlink GitHub. And you can read the Solidity that actually is checking that the number is truly random, right? So there's a little bit of cryptographic magic or cryptographic big brain that goes on behind the scenes. Well, not behind the scenes, like literally, you know, on the blockchain. So it's very transparent. But yeah, if you want to go dive deeper into how the cryptography actually works, I definitely recommend go checking out some of the smart contracts. Good question. How does Chainlink create decentralized sources when most sources today are centralized? I think I already answered that. It doesn't create, it aggregates multiple sources and aggregates many sources to create this decentralized source. Good question. In price feed, for example, how does Chainlink tackle latency issues? That's a really good question, actually. And you'll notice that there's a couple of parameters to kind of safeguard protocols from some of those latency issues. So obviously, they have gas updaters, which all the different Chainlink nodes try to push as much gas to have their updates be really, really quick. And they're also constantly checking. Excuse me, they're also constantly checking these APIs and these services for price updates. You'll notice that a lot of them have like an accuracy deviation threshold. Most of them are like 0.1% to like 0.5% or something like that. And yeah, they're constantly calling these APIs and they're pushing a lot of gas to make sure that their updates go on chain in a timely manner. Good question. How is Uniswap hybrid? Yeah, good question, actually. I'm glad you called me out on that. So for the most part, it's not, right? For the most part, pretty much everything on Uniswap is on-chain. However, there are a couple functions that for us engineers that we want to interact with that you do need some type of Oracle, right? And Uniswap actually does have an Oracle product that's TWAP, or it's time-based. So they take like, I'm not an expert here, but last time I checked, it was like a 30-minute window, and they kind of average the price within 30 minutes. But they do have a couple functions, for example, swap exact tokens for tokens, where you do need an Oracle, actually, when you do that swap. You'll notice, like, for example, when you pick like a slight, a price slippage when you're using Uniswap, in order to actually make sure that somebody doesn't kind of put a transaction before yours to take advantage of your transaction and steal more money from you, you have to actually say, hey, here's the minimum amount that I want back, right? And you actually have to use an Oracle to say, here's kind of my lowest tier that I'm willing to go to protect ourselves from, somebody using some type of minor extractable value or something like that. So there are some functions where you need an Oracle, and that using Uniswap in that fashion does make it hybrid, because again, you're using an Oracle. Good question. Really good question. That was very astute. I'm glad you picked up on that. But yeah, check out some of those like swap exact tokens for tokens, or swap exact ETH for tokens, or check out those functions, and you'll see what I'm talking about. Can Chainlink also be used for smart contracts based on IoT data? Yes. Amazing question. Yes. IoT data is data. Chainlink gets data, puts it on a smart contract. Yes, absolutely. Can we connect real-time football match scores with Chainlink and put into smart contracts? You absolutely can. Again, check out that any API feature. It'll teach you how to make API calls, which is probably what you're looking for. Great question. Is there any Oracle to get mempool data? That's a good question. I don't think so. That would be pretty cool, though. Maybe you created a data DAO for mempool data. That'd be really cool. All right, I'm going over to the chat here. These are fantastic questions, by the way. Yeah, how are Uniswap, SushiSwap hybrid? So SushiSwap is really cool, actually. SushiSwap's using Chainlink oracles to do margin trading, right? So margin trading is a type of leverage trading. And in order to leverage trades, you have to do a little bit of borrowing and lending, right? And if we're talking about borrowing and lending, we again have to price the value of the underlying collateral. I know I said a lot of like finance terms right there. So if I'm not making any sense, feel free to ask away. But SushiSwap has a margin trading protocol, right? And so it allows us to leverage our trades, and that's how they're hybrid. And the Uniswap thing, how I was saying, there's a couple functions where it actually needs an Oracle in order to stay safe when it does a swap. So that is a fantastic question. Can we use real-time football? Yep, I think you asked in the Q&A. Awesome. How does it check if it's truly random? Yeah, again, go check the code and the blog post that talks a little bit more about the cryptography that goes on to make sure it's random. Great question. How to win swag? Good question. Do amazing in the hackathon. I don't think we're doing swag at this hackathon, but stay posted, and oftentimes we'll give out swag in some of the hackathons that we participate in. Just make a valid final project submission. Oh, never mind. Denver said make a valid final project, and there you go. Can I get a link for the Chainlink Discord? Yep, it's right there. Awesome, thank you. How can Chainlink smart contracts validate the outside data? So this is a great question, and it's kind of more on consensus here, right? So I think what you're asking is how can Chainlink make sure that the data that it's reporting is the data that it's getting? I think that's what you're asking for. And this is a great question. And this is where the decentrality of the network actually really shines, right? So all of these nodes are reporting data, and they all are financially incentivized to behave honestly, otherwise get kicked off the network, or in future versions of Chainlink, even more harsh punishments. So if they want to stay on these networks, they should report data honestly, because everything that they report gets stored on chain forever, right? This is blockchain we're talking about. Everything you do is going to be on chain. So whenever they aggregate these prices and reach a point, you can actually do analytics to make sure that these nodes are reporting honestly. And if they're not, you just kick them off the feeds. Now, this is kind of a question about like, how does Ethereum validate the logic? Well, the answer is the same. It's validated by a decentralized network, right? The 51% of the nodes on Ethereum say, hey, this is how the logic should be executed, or this is the state of the blockchain. Chainlink works the exact same way. 51% of the nodes have responded with this data. So this is the state of the real world. So that's a really good question. So these were amazing questions. These were like amazing questions. When we can see Chainlink on Flow, I'm not sure. I would love to see that too. I'm not sure. But yeah, that's actually a great point that I totally skipped over. Chainlink is a blockchain agnostic technology. So it can work on any blockchain. And there's external initiators and external adapters, which allow the Chainlink node to be customized to any blockchain. That's a little bit more in depth, but we do have some videos and some documentation if you're really interested on that as well. Is there no mining when Chainlink maintains consensus? Yes, there's no mining. It's all this data aggregation and this external computation aggregation. There is no mining. Great question. Then does Chainlink have any consensus? In a way, yeah. Especially with price feeds, right? So right now, the current iteration of Chainlink is what's called off-chain reporting. All the Chainlink nodes off-chain, they reach some type of consensus on what the state of a price is. And then in a single transaction, they push that update to these reference contracts. So in a way, yes, they do have this consensus. It's a little bit different from like proof of work and proof of stake. But yeah, in a way, they do have consensus. Great questions. Seeing more questions. I love this. Dender, do we have more time? Can I answer these last three, or
yeah,
we gotta shut up now?
Yeah, like quick last questions would work.
Okay, all right, we'll be quick. These are fantastic questions. Everybody who's asking these, also jump into the Chainlink Discord. This is exactly how you learn and you grow. So I'm loving all these questions, and jumping to the Discord and really engaging with the community on Stack Overflow 2 are going to be great ways to learn more. Can we use real-time data analytics from Chainlink using centralized APIs? You absolutely can. Just keep in mind when you're building the protocol, say, hey, here's a current limitation, right? Because if you build your protocol and use a single centralized API and say it's decentralized, it's not. And people will call you out on that. How was working at Chainlink and working full-time in crypto for you? So so this is actually a good point. I actually don't work at Chainlink. I work at Chainlink Labs, and I work on Chainlink. I know it's kind of it's a weird little subtle thing there, but it's like saying, hey, how is it like working at Linux? Nobody works at Linux. People work on Linux, right? It's an open source protocol. So Chainlink is a decentralized protocol. And so if I take your question and say, hey, how's it like working at Chainlink Labs? I absolutely love it. Talk to me anytime. I will give you the whole story on. It's just I get to work with some of the brightest people in the space. I get to work on the coolest technology. I get to code. I get to give fun presentations. It's the best. It's the best. Great question. Chainlink has a contract. What if we make a SDK to help centralized servers get decentralized data? That sounds like an awesome project. That sounds like an awesome project, and I encourage you to make it for this hackathon. I think that's pretty much all the questions. Yes, I found the Oracle in the Uniswap v2, Uniswap v2 Oracle library.sol. Yep, that's another one too. What I was talking about was, oh wait, maybe that is the one. Yeah. Anyways, take a look at it. It's really cool. So, yeah. So we're definitely 15 minutes over time here. Denver, thank you so much for allowing me to go over a little bit. Thank you everybody for asking all these questions. They were phenomenal, really astute questions. I'm really excited for the different protocols that everybody builds here. Again, we will be in the Discord. If not myself, one of the other developer advocates from the team. So feel free to jump in, ask questions. Sometimes we'll reroute you to Stack Overflow just because it'll be more visible. We'll get more eyes on it and possibly a better answer for you. But yeah, really looking forward to the projects for this hackathon.
Yeah, same here. And, really excited for them. And like I actually put up the link to like we actually decided our giveaway using Chainlink's VRF. So if you remember, that was
amazing.
like really cool. And yeah, Jay had built that.
Oh, that's right. Yeah, Jay. Yeah, rank Jay. Yeah, he's great.
Yeah, I think he was attending, but then I saw him around. But then yeah,
maybe he's busy. He's busy working on Cleopatra.
Yeah, but that was like an interesting use case. So there are a lot of interesting use cases out there, and really looking forward to things being built on Chainlink. And yeah, really looking forward to it. Also, I would 100% recommend, if you want to learn more about coding and everything in particular, do check out Patrick's channel. So I put the link in the chat. Yeah, do check it out. It's really cool. And you'll definitely learn a lot from it. Yeah. All right, Patrick. Thanks a lot for joining in today. Really appreciate it.
All right. Thank you so much, everybody, and good luck.
Yeah. Bye-bye.